So here we have a side-by-side video that shows what the driver's display will show while a bicycle is approaching the car. I'm carrying the bikes module, which is represented by the yellow square on the left. I'm approaching Jonathan, who's holding the car's module, represented by the blue square. And as the bicycle gets closer and closer, eventually it'll reach our threshold distance, which we've set to 10 feet, and the square will turn red, which alerts the driver of a nearby bicycle and hopefully prevents any accidents from happening. Now we'll go over some ways that we improve the performance of our system. So here you're seeing two displays. On the left, it's a idealized version where there's absolutely no packet loss. There can't be packet loss because we've written lines and lines of GPS coordinates for the bike that would make it move around a stationary car. And all we've done is we've had our computer read from those, the file contain all the GPS coordinates, and go through our math for the display to show the bike revolving around the car. On the right is the same GPS coordinates, but this time instead of the computer reading from them internally that has the display, they've been transmitted across a channel. And as you can see, the performance is way, way worse here. Sometimes the bike doesn't even move at all for a long period of time, and then it'll jump up to catch up and hop around. And this is because a lot of the packets were dropping during the transmission. And so we had to come up with a way to improve that. And we ended up using forward error correction to add a little bit of redundancy to the packets so that even if some bits of them are dropped, our receiver was still able to determine what the coordinates were. Now here's the same deal. The left is the idealized version where it's just reading straight from the computer, so there's no transmission. And on the right, there's now transmission. This time the transmission has forward error correction programmed into it though. And we can see that the packets are being received much more frequently, and it's matching what the actual scenario should be way, way closer. There's no massive jumps to catch up or lags where the bicycle just stands still for a little bit. It's able to map the actual movement of the bicycle to the car much better thanks to the forward error correction programmed into the SDRs.